Hello everyone. So this is a question from RE-NEET 2026 for an elementary chemical reaction. Okay. Uh, Elementary chemical reaction is a reaction that occurs in a single step. Okay, important. The Arrhenius plot. Arrhenius plot is a graph in which the y-axis we have ln k, where k is the rate constant, and in the x-axis we have 1 by t, where t is the temperature. Okay. So the Arrhenius plot is given below. So this is a graph given to us. If the energy of activation is 6.64 kilojoules per mole, okay, and gas constant is 8.3 joules per Kelvin per mole, the temperature at which the rate constant becomes E square per minute or minute inverse is. Okay. So the chapters involved is chemical kinetics. And according to Arrhenius equation, we know that um, K will be equal to A e to the power minus EA divided by RT. Okay, so it is A into e to the power minus EA by RT. Okay, where K is our rate constant, A is our pre-exponential factor, or it is also known as frequency factor. Okay, EA is the activation energy, R is the gas constant, and T is the temperature. Okay, so let's say this is equation 1. Since they have given a graph of ln k versus 1 by t, so therefore let's take logarithm of both sides of equation 1. Okay, so let's take the log of both sides of this equation. So this will become ln k will be equal to ln of the RHS, that is A into e to the power minus EA by RT. Okay, so I can write further ln k is equal to ln of A plus ln of e to the power minus EA by RT. Okay, so I'm using the law ln of C into D is equal to ln C plus ln D. Okay, so therefore you can see I can write this as ln A plus ln of this term e to the power minus EA by RT. Okay, so I can write further ln K will be equal to ln A plus minus EA by RT into ln E. Okay, so I'm using the law ln of C to the power n is equal to n ln C. Okay, so the power, whenever you take the power of something in log, it comes out of the log. So ln of C to the power n becomes n into ln C. So here this term ln of e to the power minus EA by RT became minus EA by RT into ln E. Okay, so I can write this further as ln K is equal to ln A minus EA by RT. That's because ln of E is 1. Okay, so I can rewrite this as ln K is equal to minus EA by R and keep 1 by T separate plus ln A. Okay, so let's say this is my equation 2. Okay, remember the general equation of a straight line is y is equal to mx plus c. Let's say this is equation 3. Okay, where this m is the slope of the line and this c is its y-intercept. Okay, so in the graph that they have given, that is ln k versus 1 by t, on y-axis they have taken ln k and x-axis they have taken 1 by t. Okay, so therefore comparing equation 2 and 3, in the graph they have taken ln k as y, in the graph they have taken 1 by t as x. So you can see the slope of the graph, that is m, is minus EA by R. Okay, And also, can you see the negative sign? That's why the graph is like this and not like this, because the slope is negative. Okay, and C is ln A. Okay, the y-intercept is our C and C is ln A. Okay, so y-intercept, what is y-intercept? Y-intercept is the point where a line crosses the y-axis. Okay, very important. Y-intercept is the point where a line crosses the y-axis. Okay, so in the graph that they have given, ln k, that is our y, versus 1 by t, that is our x, the graph is like this, and this value is 6. So you can see this is the point where the graph crosses our y-axis. This is our y-axis. Okay, so therefore our C, or ln A, that is the y-intercept, is nothing but 6. So ln A is equal to 6 because the graph crosses the y-axis at this point. Therefore this value, that is the intercept, is 6. That's why I've written ln A, or the intercept, is equal to 6, because when we compare them, ln A is nothing but C, which is the y-intercept. Okay, and also they have given EA, that is the activation energy, is equal to 6.64 kilojoules per mole. So I can write this as 6.64 into 1000 joules per mole. Okay, next they have given us the value of R, which is 8.3 joules Kelvin inverse mole inverse. Okay, and K, that is the rate constant, they have given to us as E square minute inverse. Okay, so using these values and also the value of ln A as 6 in equation 2, remember this was our equation 2, so I can substitute values in equation 2. So ln of k, we have, instead of k I will write E square, will be equal to minus EA by R. Okay, so minus of activation energy is 6.64 into 1000 divided by R is 8.3 into 1 by t. T is what we are supposed to calculate, plus ln A, we calculated that as 6. Okay, so ln of E square will be equal to 2. Okay, that's because remember we can take the power out from log, so ln of E square is nothing but 2 into ln E, and ln E is 1, so that's why ln of E square is 2. Okay, so I can write 2 is equal to minus 6.64 into 1000 divided by 8.3 into 1 by t plus 6. Okay, so bring this 6 towards LHS, so this becomes minus 4 is equal to minus 6.64 into 1000 divided by 8.3 into 1 by t. Okay, minus minus gets cancelled, so I can write 1 by t is equal to 4 into 8.3 divided by 6.64 into 1000, or I can write t is equal to 6.64 into 1000 divided by 4 into 8.3, which will be equal to, so when you do this calculation you will get t as 200 Kelvin. Okay, so therefore the temperature at which the rate constant becomes E square per minute is 200 Kelvin. Okay, thank you.